Hi everyone, in today's lesson we're going to talk about the motion of a particle moving across a horizontal line. So what we're going to do is we're going to map out the trajectory of a particle. We'll say this red particle and its motion across a horizontal line. So it could move forward, right? Then it could go back a little bit, maybe end here. Then it could go forward, right? And it could do that. So we normally, with this overlap like this, the particle moving right and left, we're actually going to show it in a different way. We would say, okay, here's the particle where it starts. It moves to the right. Then it's going to go to the left. And then it'll go back to the right. So drawing these little spaces up can really show from here to here I'm going right. And from here to here I'm going left. And from here to here I'm going right. But really it's on this one horizontal line. I've just put these little spaces here to just show which way it's going. So before we can do some examples, we need to talk about some vocabulary first. So standard position. Standard position is defined as the position of the particle on that horizontal line at any time t. And we denote standard position as x of t, or sometimes it's referred to as s of t. Velocity is the constant speed of the object moving forwards or backwards over time. And that is the first derivative of the standard position, or sometimes referred to as v of t. Acceleration is the change in velocity over time, so a speed up or a slow down type situation. And this is the second derivative of the standard position, or sometimes referred to as a of t. And the particle is at rest when the particle is at a standstill, so when I'm not moving. So we are at rest when my velocity is equal to 0. We are moving forward when the particle is moving right, when I have a positive velocity. So v of t is positive. Or in other words, we could say v of t is greater than 0. And moving backward is when the particle is moving left, or when v of t is negative, or in other words, when v of t is less than 0. So these are the main definitions that we are going to use as we go through an example. So we've got three main, functions. We have standard position, velocity, and acceleration. Standard position is the original function. The derivative of that is my velocity, and the derivative of that one is my acceleration. We're at rest when the velocity is equal to 0. We're moving forward when the velocity is greater than 0, and we're moving backward when the velocity is less than 0. So let's put this into an example so it'll make more sense. Okay, so example number 1 says, a particle moves along a horizontal line according to the function s of t equals this, when t is greater than 0, and time is measured in seconds, and s of t is measured in meters. So this function will tell me where the particle moves across that horizontal line. So the first part is asking you to find the velocity of the function. So if you look at the definitions from the chart in the previous slide, we know that the velocity is defined as s prime of t, or the first derivative. So we start with s of t, which we could write it as x of t, they're interchangeable. So x of t is equal to 2t to the third minus 15t squared plus 24t plus 8. And x prime, or my first derivative, is my velocity. So taking the derivative, we're going to use the power rule. So this is 6t squared minus 30t plus 24. And that is my velocity function. So you could even write it as v of t. That's the same thing, v of t or x prime. So this way or this way. Just know that the velocity function is my first derivative. Okay? Now, part B, I'm asking you to find the instantaneous velocity at 2 seconds. So when I'm talking about an instantaneous velocity, I'm talking about an instantaneous rate of change, or an instantaneous slope. So slope is derivative. So all we're going to have to do is, if my v of t function is 6t squared minus 30t plus 24, if I want to find the exact velocity at 2 seconds, all I'm going to do is plug in 2 into my velocity function. So 6 times 2 squared minus 30 times 2 plus 24. So go ahead, pause the video, and hit resume when you're ready for the answer. Okay, so you should have gotten negative 12. So what that means, that negative 12, means you have a negative velocity. So what that means is that at x equals, or time equals 2, you are going to move to the left, right? Because negative velocity means we are moving left. So a velocity of 12, but moving left. That's what that means, at time equals 2. And I'll show you in a picture how that makes sense in a little bit. Okay, so the next part, I'm asking you to find where the particle is at rest. So again, if you look at the chart, you'll know that a particle is at rest when it's not moving, or when the velocity is equal to 0. So we're going to take our velocity function and we're going to set it equal to 0. So 0 equals 6t squared minus 30t plus 24. And we're going to solve. So I think I can take a GCF out of 6. And what I get on the inside is t squared minus 5t plus 4. And now I'm going to factor using add multiply. So what numbers add to negative 5 that multiply to 4? And that is t minus 4 and t minus 1. So when I do my t chart, 6 equals 0 makes no sense. I reject that one. Here we get time equals 4 and time equals 1. So what you just found out was at time equals 1 second and time equals 4 seconds, my particle is at rest. Okay, so now part D is asking us, well, when is the particle moving forward, right, and moving backward, left? Well, the only way that we can do this is we have to draw a sign chart. And I'm going to be more specific, a V of t sign chart. Okay, so what does that mean? So I'm going to draw a line, and here is time equals 0, and I'm going to put the particles at rest here, 4 and 1. So I'm going to put 1 here, and I'm going to put 4 here. And we're going to test some values. So let's choose a number between 0 and 1. So I'm going to choose 2. And let's choose a number between 1 and, the number that I'm going to choose between 0 and 1, we'll say is 0.5. And then between 1 and 4, let's say 2. And then a number greater than 4, I could choose 5. You can pick any numbers that work that are in between these values. And what we want to do is see if the velocity function is positive or negative. So since this is my velocity function, v of t, we want to see what is happening at v of 0.5, v of 2, and v of 5. So take a couple minutes and substitute 0.5 for t, and 2 for t, and 5 for t, and get me 3 values, and then hit resume when you're ready for the answer. Okay, so 10.5 is what I got when I plugged in 0.5. 12, negative 12 when I got 2, right? Same for over here. 24 and when I got 5. So since this 10.5 is positive, that means we're going to put pluses here. So that means between 0 and 1, my velocity is positive. Because at 2, I got a negative 12, that means all values between 1 and 4 will have a negative velocity. And because I had 24 is positive, and when I plugged in 5, then that means after 4, I'm going to have a positive velocity. So remember, positive velocity means moving forward. Negative velocity means moving left. So if we need to write that, moving forward and then moving left. So moving forward is when v of t, so positive velocity, when v of t is greater than 0. Moving left is a negative velocity, or when v of t is less than 0. So to answer the question, when is the particle moving right and when is the particle moving left? So forward or right means the same thing, so let's write it down. So the particle is moving right from 0 to 1 and from 4 to infinity. So we're just going to write it in notations. So 0 to 1, union means and, 4 to infinity. And the particle is moving left from 1 to 4. So I'm using interval notation. 1 comma 4 means all numbers between 1 and 4, not a point, 1 comma 4, x, y. So the answers to your question are these. It's moving right from here to here and moving left there to there. Okay, so the last part is going to be to draw a diagram of this picture to represent the motion of this particle. So in order to find out where we are at any given time, we need the standard position. So we need our s of t function, which is our original. So let's go all the way back up to the top and copy down our original function. So our original s of t is 2t to the third minus 15t squared plus 24t plus 8. And our goal is going to be to figure out where we are exactly at time equals 0, 1, and 4. So let's go ahead and plug in 0, plug in 1, and plug in 4. And pause the video until you've done so, and then hit resume when you're ready for the answers. Okay, so when time is 0, you should have gotten 8. When time is at 1, you are at 19. And at time is 4, you are at negative 8. So what you just found, these values are your position on the horizontal line. So position on horizontal line. So if we draw that horizontal line that we speak of right along here, and then we're going to put these 3 values on that line because those are the positions on the horizontal line. So say 0 is in the middle here, we could put negative 8 here, positive 8 here, and positive 19 here. And what you're going to do is at time equals 0, you're going to plot a point at 8. So 8 is here, and you can go ahead and label that time equals 0. And then we move, for when time is 1, we're moving to 19. So I can go ahead and put another dot here at 19 and say this is at time equals 1. And then the last thing at time equals 4, we're at negative 8. So we're going to put another dot at negative 8 and call this time equals 4. So technically along the horizontal line, we're starting at 0, going to the right to time equals 1, going back to negative 8 at time equals 4, and then we're continuing to the right forever. And notice that it's going to follow this time frame. From 0 to 1 in time, we're going to the right. So 0 to 1, we went to the right. Then from 1 to 4, we went to the left. So 1 to 4, we went to the left. And then from 4 to infinity, we just went positive to the right. So this would be your picture that represents the motion of the particle. All right, if you have any questions, now's the time to jot them down, and we'll see you in class tomorrow. Okay, have a great night.